So what we're going to do, we're going to look at stuff that is a line. So we have y equals, let's just say 3x minus 4. So first let's remember how to graph a line. Remember, this is where we start. This is the y-intercept, which tells us a point on the line. We know that we can go down 1, 2, 3, 4, and we have the point 0, negative 4. That's the first point of our line. Does everybody agree with that? If you're at any point on a line, you can use the slope to find the next one. And the slope here happens to be 3 over 1. So you go up 3. Do you go to the left or to the right one? To the right one. I prefer to make a second point always, just to fully understand the fact that you can go anywhere from using the slope. Then we just connect our line. Okay. So the question is that even an inequality? Was what I just drew an inequality? No, it's not. What does an inequality have to have? A greater than, a less than, or a greater than or equal to and less than or equal to, right? Alright, remember, the greater than is the big side, the less than is the skinny side. So it goes from big to skinny. So the pointy side is the less than side. If you have to, just remember the alligator is hungry, so he eats the big number. I don't really care how you remember it, as long as you remember it. I was in music when I grew up, so I never had any trouble figuring it out because it looks exactly like a crescendo and a decrescendo. So if that's how you want to remember it, you can remember it like that too. Okay, so what if we have something like this? What if we have y is greater than 2x minus 1? Greater than or equal to 2x minus 1. So, first of all, I'm going to graph my line. I go down 1, then I go up 2 to the right 1 from there. Does that address the greater than, though? Did I do anything differently than I did in the first problem? No. Which means that I'm leaving something off. And if you think about what this means logically, is y is anything bigger than this line. Does that make sense? That's what it says. Y is bigger than that line. Right? So basically what it says is y is past that line. Does everybody agree with that? Like if you drew a line on the floor, you would say everything past this line is okay. And that's exactly what we're going to do here. Since it says it's bigger than, we are going to color above or below. Above, it's bigger. Oops. Do you remember doing that last year? It's so. I prefer it to be pretty neat. Like, a lot of people would do something like this. So please don't do that. Please just have little shading like this. It looks a lot nicer. And a lot of times if some people do this, it messes up their line. So I'd prefer you to shade like this. Okay, let me have you try one like that on your own. Except you're going to do y is less than or equal to 3x minus 4. So here what we're going to have, if you noticed, it's the exact same line from the first one. So you shouldn't have had any trouble drawing it. I prefer at least 3. If you want to draw 4 just to straighten up your line, that's fine. But having 3 is about it. There's 2 reasons I make you all do 3 points. First of all, it makes your line straighter. Second of all, it helps you understand that the slope isn't just 1 point to the second point. It's any point. Okay, this says y is less than, so we shade underneath it like this. Okay? Everybody happy? When it's greater than, it's shaded above. When it's less than, it's shaded below. Yes?
I don't understand how you got the points. Do you go X over 3 times?
I go up 3 to the right 1. Remember, this is the y-intercept. So that's where it crosses the y-axis. So I go down 4 first. And then from there, I use the slope to find every other point. I go up 3 to the right 1, over and over and over again. Okay, moving on. There's a couple tricky things. The first thing is, what if you have y is just bigger? This time I'm going to have 1/2 x plus -5. What happens if you just have it being bigger? And I will tell you that it is much easier to do this in pencil. And I'll show you why here in just a second. So firstly, I go down 1, 2, 3, 4, 5 because that's what this is. From there, I go up 1 to the right 2. I can actually go down 1 to the left 2 if I wanted to as well. Okay, and I have my line. The trick though is this actually equal to the line? It can never be equal to it. So does anybody remember what we do? Yeah. What? You make a dotted line. So the easiest way to do this and make them straight is to do it in pencil, draw your line, and then erase little chunks out of it. Why is it dotted? Because see, yeah. Again, it's dotted because of this right here. Because it doesn't have an equal to underneath it. Let me have you try one of those on your own. Right, so, again, this is the line we start with. I think it's easier just to go back and erase using a pencil to make it a dotted line. Yeah, but mine's computer generated, so. Okay, and then, oops, I forgot to shade this one over here. So this is greater than, so it's actually shaded above. This is less than, so it is shaded below. What? Yes. Because what you're saying is it can be any number down here. So you're shading down there to say that anything down here satisfies that equation. And trust me, that is not an easy thing to understand what I'm saying there. Okay. The problems creep in when we have something like this. 2x plus 3y is greater than or equal to 5. Now let's make that a little bit easier and make it 9. Okay, do you know how to graph this?
Yes. No. Yes.
Alright, do you know how to graph this? You at least you should have a halfway idea of a couple ways to do it. What would be the easiest way to do it? Believe it or not, the easiest way is to find the intercepts, but that might be too much work for you. So what we're going to do, we're just going to subtract 2x from both sides, and that gives us 3y is bigger than or equal to negative 2x plus 9, and then we're going to divide by 3. I think this would be the easiest way for you all to graph it. Do you all agree? There is actually an easier way, but it's another thing that you have to remember. And I would prefer that you remember one thing and remember how to get it to that shape. So, now we're in the same position that we were. Here, instead of starting down 3, we start up 3 because of this number right here. So we start up 3. From there, we go down 2 to the right 3. Again, down 2 to the right 1, 2, 3. And I get my points. I can also do one up 2 to the left 3. Is this a dotted line or solid?
Solid.
Solid line, and it's shaded above.
Now, how do you know when it's solid or dotted?
I'm about to explain. Okay, so let's recap real quick. How do you know if it is solid or dotted? The answer to that is, let's make a little chart. It all depends on how it reads. Y is bigger than x. Y is less than x. I'm not giving myself enough room. Y is bigger than or equal to x. Y is less than or equal to x. So, this means it's dotted. This is solid. And again, somebody already said it, because it has the equal sign below it. Right? What? What'd you say? It is exactly like that. It's just like bubbling in the circle like we did yesterday. You look for the exact same thing. And if you think about it, it logically means the same thing. An open circle and a closed circle is basically the same thing as this, right? Just two different ways to show incompleteness. Okay. This is shaded above. This is shaded below. This again is shaded above. This is shaded below. And again, it's by the way it reads. If it reads that y is bigger than x, then it's shaded above. If it reads y is less than x, then it is shaded below. Any questions?